In this video, we're going to be learning about the three parallel lines theorem. And this theorem says that if three parallel lines intersect two transversals, then they divide the transversal proportionally. So we can see an example here. I have the three parallel lines R, S, and T, and I see they're being intersected by two transversals, L and M. And we learned from this theorem that that means it's dividing this proportionally, so that UW over WY is equal to VX over XZ. And again, remember just to notice that the corresponding sides are both on the top or bottom. So since UW matches up with VX, they are both on top of my fraction. And same thing with WY and XZ. So let's go through a couple examples. So here I want to find the length of the given line segment. So I first want to find the length of BD, which is right here. And so I see that I do have three parallel lines. And the reason why I know these are parallel is because these angles 1, 2, and 3 are congruent. And I see those are corresponding angles. And so if you remember back in that unit, if the corresponding angles are congruent, then that means that the lines are parallel. And so since these lines are parallel and they're being cut by transversals, I know that the sides, it's cutting the sides proportionally. And so that means that AC over CE is equal to BD, which is the side length here, over DF. AC has length 16, CE has length 40. Trying to find BD, DF has length 30. Now that I have my proportion set up, I can go ahead and cross multiply. So BD times 40, and I get 40 BD is equal to 16 times 30, which gets me 480. And then divide both sides by 40. And I get that BD is equal to 12. Again, you can always flip these around if you want. You could add CE and DF on top instead, and the other two on the bottom. You'll still end up with the same answer. Okay, let's try one more. So here I want to find the length of JM, which is right here. So first I'm looking to see if these lines are parallel. I see that these are all right angles. We know that all right angles are congruent because they're all 90 degrees. And I see that these are also corresponding angles. So we know from that corresponding angles theorem converse that these three lines are indeed parallel. And so now I can go ahead and set my proportions. And so I see I'm going to start with JM on top this time. So I have JM over JG is equal to the side that corresponds with JM over here is going to be KN over HK. I don't know the side length of JM. JG has length 16. That's going to be equal to KN, which is 18, over HK, which is 15. And now I can go ahead and cross multiply. So JM times 15, I get 15 JM. It's equal to 16 times 18, which is 288. Divide both sides by 15. And I get that JM is equal to 19.2.